This is a final test of 41991. This is an NAD amplifier. This had a plethora, big word for the day, plethora of problems, um, numerous intermittent problems with both channels, and it's rock solid now. So what we're going to do is run a laboratory audio generator into the CD inputs. We're going to monitor the output on this device here, which is a dual trace oscilloscope. We don't have a camera person here. This is not a Hollywood operation. That device with the two horizontal lines right there. The upper line will display the left channel. The lower line will display the right channel. And the software is slow as molasses. As we're viewing this, the phone rings. Of course. Good afternoon, stereo surgeons. Okay, we're back live after that phone call. And as we're viewing this, to the left, as we're viewing to the left of the oscilloscope, there are two sets of digits. Those are frequency counters, one on top of the other with a multimeter in between. On top of the top frequency counter, you can see two little orange dots. They are the 0 points of horizontal bar graph, which is going to represent the amplitude that is in parallel with the oscilloscope, and it's going to show us in decibels different changes. It's a lot easier than trying to interpret changes in the oscilloscope amplitudes. And it's also going to allow us to perform frequency response tests, and it's also a distortion analyzer. So we're going to turn it on, and let me turn the volume all the way down here. The item, like most amplifiers, let's get a good look at this here. The item, like most amplifiers, employs a 5 to 10 second turn on delay. And what am I doing wrong here? It's just totally unrehearsed. There you go. And within 5 to 10 seconds, protection left. And we're into CD mode. We're going to turn this up, and you're going to hear. Yeah, you're going to hear. Okay. With the speakers on, you're going to hear. Again, this is unrehearsed. And hopefully that is not distorting the microphone or totally drowning myself out. But let's take a look at the oscilloscope here. And as I operate the volume control, you can see the amplitudes changing. So what I'm going to do is go and switch the speakers into what's called a dummy load. I'm doing that right now. Dummy load stresses the amplifier, same as a speaker, but it converts the audio energy into heat rather than sound. That way we don't blow up speakers or my eardrums as we turn the volume up. First thing let's do is run this bad boy to full power. And so I need to get some more gain here. Let me flip that down. Full power is achieved when, I think we should get a little closer to the scope. Oh yeah, we want to see the bar graph display too. There we go. Full power is achieved when the top, we're just starting right there. How about that? This has a soft clipping on this. Let's make sure we're not running that. That switch is back here somewhere. Yeah, okay. Now we're not running soft clipping. And so I want to get a little more room here on the scope as we draw the power up. Full power is achieved when the top and the bottom of the sine waves start to flatten out. That's called saturation. If we run it at that point very long, we will destroy output transistors because the current draw is much higher than it's designed to. So I'm just rocking this back and forth. It also sounds extremely distorted. So we can drive both channels to full power. The other thing we're going to do is do a frequency response test. And for this, we want to really look at the bar graph up here. And we want to make sure as we go through the different frequencies that it doesn't change appreciably. It might change a half a decibel or a decibel over the entire range. Right now, that's 400 hertz. Okay, and as we change the frequency, you'll be able to see the period displayed change. So we're at 400. I'm going to go to the very bottom of the audio chain here, which is going to be, it's about 20 hertz. Okay, so now we're going to step this up. You can hear this too. Hang on. Maybe you can't hear 20. Let's step this up. You may be able to hear 40. That's 60. And that's getting real loud, so we're going to go back to the dummy loads. But you notice the bar graph's not changing. And we don't want it to change. That means there are no amplitude changes in either the left or the right channel as we change the frequency. We want it to be flat, much like my ex-wife's chest. There we go. We always have to throw in a little ex-wife humor. Very little. Okay, we're going to keep going on this. And I can tell you in a second where we are frequency-wise, but we're up there into the range of dogs and bats. That right there is 20K. Yeah. So it's essentially flat across the entire audio spectrum. We're going to go back to 400 hertz, which is pretty much where we like to hang out. Going to turn that back down, and that's going to be the end of our test. Oh no, I want to show that the item is rock solid. So let's do one other thing here. I'm going to go back to the dummy load, and we're going to watch the oscilloscope as I bang on the boards, bang on the output relay. If I can find it. There we go. Notice the amplitude is not changing. When this item came in, the relays were intermittent. The boards had numerous heat stress connections, numerous to the point where all I had to do was apply just gentle torque, and that just by putting the item on its side or just slightly picking it up one corner or the other would greatly affect one channel being there or not. And the item is now rock solid. Okay, that's the end of this test. We're going to email this to my friend Scott, and we move on.